In this session, we are going to discuss a numerical on application of Bernoulli's equation. The question says, the water is flowing through a tapered pipe of length 100 meter having diameters 600 mm at the upper end and 300 mm at the lower end at the rate of 50 liters per second. The pipe has a slope of 1 in 30. Find the pressure at the lower end if the pressure at the higher end is 19.62 Newton per centimeter square. So here you are asked to find out the pressure at lower end. So for us to apply the Bernoulli's equation, we have to choose two sections, and here we have chosen the upper end as section 1 and the lower end as section 2. So you are asked to find out pressure at lower end, which is P2. So let's write the Bernoulli's equation at these two sections. So we get it as P1 by rho g plus V1 square by 2g plus Z1 equal to P2 by rho g plus V2 square by 2g plus Z2. Now, after writing the Bernoulli's equation, our aim is to check what all parameters are given to us and what all parameters can be computed with the data available in the question. So here P1 is the pressure at upper end, which is given to you in the question as 19.62 Newton per centimeter square. Now here you should remember that every numerical we are going to solve it in SI units. So all your parameters must be in their SI units. So here that 19.62 Newton per centimeter square should be converted to Newton per meter square when you are substituting it in the Bernoulli's equation. Now moving on to the second term in your Bernoulli's equation, which is the kinetic head V square by 2g. So we will be having V1 square by 2g for section 1 and V2 square by 2g for section 2. So here we are not given with the velocities V1 and V2 directly. But when you go back to the question, you find that you are provided with discharge as well as the diameters of sections 1 and 2. So whenever we are solving Bernoulli's equation, the majority of times we will have to apply or we will have to use a continuity equation. Okay, and you know that a continuity equation is Q is equal to A1 V1 equal to A2 V2. So it is from the continuity equation that we are going to find out or we are going to compute out our velocities V1 and V2. So V1 will be Q by A1 and V2 will be Q by A2. So Q, the rate of flow or discharge, is given to you in the question, which is 50 liters per second. Remember to convert it into its SI unit, which is meter cube per second. And note that 1 liter equal to 10 raised to minus 3 meter cube. So our discharge will be 0.05 meter cube per second. Once we have our Q with us, now we will have to calculate A1 and A2. So diameter at the upper end, that is D1, is given to you as 600 mm, which will be 0.6 meter. Compute out A1 from the formula pi by 4 D1 square, which you will get it as 0.2827 meter square. Similarly, you are given with the diameter at the lower end D2, which is 300 mm. Okay, substitute the value of D2 in meters to get your A2 as 0.07068 meter square. So now we have a Q and A1, similarly A2. So you can easily find out your V1 and V2. So substituting the values of Q and the cross-sectional areas in the respective equations, we will get V1 as 0.177 meter per second and V2 as 0.707 meter per second. So now we have completed the first two terms of our Bernoulli's equation. Now moving on to the third term, which is the datum head, that is your Z1 and Z2. So if you are going back to the equation, going back to the question, you find that nothing is given about your datum heads. Datum heads are not directly given. So we will have to put in some assumptions for us to get, or for us to arrive at your datum head. So in this case, what you will be doing is, in such cases, we will be assuming our datum to pass through the lowermost section of pipe that is given to you. Okay, we will pass the datum line to pass through the lowest section. So here if you see, our lowermost section is section 2. So now datum line is passing through section 2. Now what is the advantage of assuming such a datum line? You know that datum head is the vertical distance between the datum line and the section you have chosen. Okay, so now when we have chosen our datum line to pass through section 2, your Z2 becomes 0. Okay, always our method of calculation should be such that we could simplify our steps. So now, because of this assumption that datum is passing through section 2, our Z2 has become 0. Now only task for us is to find out our Z1. Now this can be done in two ways. One is a conventional method. That is, if we are going back to the figure, you find that a small triangle is formed and your Z1 can be found out from that triangle. Okay, so if you are going back to the question, you are given with the slope. Okay, slope is given as 1 in 30. You are also given with the length of that tapering pipe. So the slope means, you know that slope is tan theta. Tan theta is equal to 1 by 30, from which you can easily find out that theta, the angle. Then by taking the sine of this triangle, you will be finding, or it will be easy for us to find out your Z1. On taking sine theta, you will get your Z1, which is the datum head. Okay, so you get your Z1 as 3.33 meter. Now there is another simple step. Okay, if you are assuming that theta to be small, your Z1 will be the given slope into length. So that is what the second method that they have done. Z1 is equal to 1 by 30, which is the given slope, into the tapering length 100, which you will again get it as 3.33 meter. So remember, there are two ways for us to get that datum head. Either by the conventional method that you use, you can solve the triangle. Okay, we will be solving that triangle and then getting your the required datum head, or simply the given slope into tapering length. So in different texts, you can find both the methods being used. So it's always easy for us to go through the easier steps which are more easy. So this formula, that slope into the tapering length, will be more easy for you. So now we have got all the parameters available. Substitute all these values in your Bernoulli's equation. Only unknown is your P2, which is the pressure at lower end. Solve for P2. So finally, substituting the values and you will arrive at your P2, which you will get it as 228,573 Newton per meter square. That is, pressure at lower end is 228,573 Newton per meter square. Thank you.